The question says that the shaft of an electric motor, okay, starts from rest, and on the application of a torque, okay, it gains an angular acceleration given by alpha equal to 3t minus t square. So let's start by writing this down. Alpha is given to be 3t minus t square. During the first 2 seconds after it starts, after which alpha becomes equal to 0. So the angular velocity after 2 seconds will be equal to how much? That is the question. Now alpha in terms of the angular velocity, as you know, okay, alpha in terms of the angular velocity is given by d omega by dt, right? It is the rate of change of the angular velocity. So angular acceleration can now be replaced with d omega by dt equals 3t minus t square. And now I integrate this so that I can get the value of omega like this. So I'll write d omega equals 3t minus t square times dt. And I integrate both sides so that I get the value of omega as 3t square upon 2 minus t cube upon 3 plus some constant, right? So now as you can see from the problem, we have been told that when t is 0, okay, then the omega itself will be 0, right? Because it starts from rest. So therefore I will say that when t equals 0, omega is 0. Therefore the value of c can be calculated like this. That means the c is also 0, which implies that my omega equation is now given by 3t square by 2 minus t cube by 3 itself. Now we have to find out the angular velocity at the end of 2 seconds. So if we now put the value of t equal to 2 seconds in this, I can find out the value of omega. That means omega can be calculated as 3 times 4 by 2 minus 8 by 3. And this shall be equal to 6 minus 8 by 3, which is equal to 10 by 3 radians per second, right? So therefore the correct answer will be 10 by 3 radians per second, which is choice number C.